Hello, my name is Peter Shak and I'm going to take you through engineering mathematics, that is Laplace transform. So we begin. Laplace transform is an important concept in the engineering sector and it is necessary for every engineer to know Laplace transform. The expression for Laplace transform, we write a capital F and a capital S is equals to the Laplace transform of f of t, which is equals to integrating from 0 to infinity exponential raised to negative st multiplied by the function of t differentiate with respect to t. So now we come and say, for example, the Laplace transform of sine at. We begin with sine at. So we come and write down L Laplace transform of ft is equals to integrating from 0 to infinity exponential raised to negative st, we multiply by the function of t now is our sine at dt. So now we do a rule called integration by parts. We have two parts in that expression, and the integral we represent it with a capital I, which is equals to uv minus integrating du over v du over dt dt. Now we say the u is this first section here, e minus st, and du over dt is equals to, because we need a du over dt, we say it is negative s e raised to negative st. We're not concerned with t because it's what we are differentiating with respect to, so we are concerned about this. So every rule of exponential, the first value comes in front of the exponential value that has been raised to negative st. Now we come to, we don't have v, but we have dv over dt. dv over dt is our sine at dt. So when we want to get v, we integrate dv over dt, which is equals to integrating sine at, which is equals to 1 over, that is negative 1 over a cos at. When we integrate sine, we get cos according to the rule of trigonometric ratios in the integration. And when there is a value that is attached to what we are integrating to with respect to, the value becomes a fraction. We divide that value with the cos, the trigonometric ratio, that is cos, and it becomes a negative. When you integrate sine to cos, it becomes a negative of that value. And now we come and rewrite this expression here. It is, our u is e raised to minus st, you multiply by negative this one here, 1 over a cos at. You subtract, our v is negative 1 over a cos at, that is what we are integrating, negative 1 a cos at. You multiply by our du over dt, negative se, that one. So now we come and rearrange these values. So this is I is equals to negative e over a, this is raised to negative st, multiply by cos at. Very good. Come here and you say, you bring these values outside s and this one. So this one times this one negative times negative get a positive, so it is minus 1 s over a, because 1 over a times s is s over a. Integrating e minus st, then you multiply by cos at dt. We still see that we can't arrive to the solution of the expression by this only here, so we need to do another integration by part, the second part of integration, which is we get the second integral. We do our integration by parts again, so we come and say I is equals to I2 is equals to e minus st, that is integrating, times cos at dt. So we need to do integration by parts again. Now we say uv I2 is equals to uv minus integrating v du over dt dt. Our u here is e minus st, and du over dt is equals to minus s e, as we had done here previously, and the dv, we normally say we don't have v, but you can get it by dv over dt, which we already have it, which is cos at. So v is gotten by integrating dv over dt, which is equals to integrating cos at, which is 1 over a sine at. When we integrate cos, going back to sine, we integrate cos to get sine, and the value attached to what we are integrating with respect to, that is t, becomes a fraction of the sine, or we divide it with the sine. So we now rewrite the whole expression. I is equals to, begin from here, negative e minus st over a cos at minus s over a into, we use a box bracket because it's quite bigger. This expression now, our first u is this one, e minus st was, so is equals to, u is e minus st over v is 1 over a, that is a, we write a sine at minus integrating v, our v is 1 over a sine at se minus se raised to minus st. So this one is our value for, this is v and this is du over dt. This one is our u, this one is our v, these parts. So now we come and combine both the two of them together, and now we say I1 is equals to negative e raised to minus st over a cos at minus s over a, open a box bracket. Now we come to this integral 2. We place this, because this one is supposed to be here, because it's what we were solving for here below. And now we say, we rewrite e minus st over a sine at minus integrating from, that is, now we remove this one outside the bracket, the integration sign, which is s over a So minus times minus, it becomes positive. Hope you are together until there. Minus times minus, it becomes positive. This one is this one. This one times this one is positive. So plus s over a integrate e minus st dot sine, let me write it here down, plus s over a let me do this way, plus s over a, save on space, integrating e minus st sine at dt. And when you look at this expression, it takes us back to here, to this part here, this one, when you look it very well. So this is our first integral, which we have written here, our first integral. This one here, it's our first integral that we have solved here. So we go back to here. So instead of doing this, we say this is I1, because this is our I2. So I1 is this one, is already replaced. So I1 is equals to e minus st, this is over a cos at minus s over a, you open a bracket, e minus st over a sine at plus, this is s over a I, s over a I1, because this we have gone back to I1. That's why I want to write here aside, but I1 is equals to e minus st sine at dt, e minus st sine at dt. Now we come and say, so we replace I1 here, as we rewrite down there. So I1 is equals to e minus st over a cos at. Now we need to do what we call opening this bracket. So we open this bracket minus, so this will be s over a squared e minus st sine at plus, open, a squared over a squared I1. Hope you are together mpaka hapo, up to there. So I1, to bring this one to this side, minus, no, it is minus here, sorry, supposed to minus, because we are opening a bracket. Negative times positive is negative. So when we bring it this side, it will be plus a squared over a squared I1 is equals to this one now, e minus st over a cos at minus s over a squared e minus st sine at 0 and infinity. Till there, I hope we are together. So now, we open this bracket here, or we put that in a bracket. So I1, put it as a subject, will be 1 plus s squared over a squared is equals to, now we need to put this one into the limits that we have, e minus s infinity over a cos a infinity, we subtract e minus s 0 cos a 0 over a, we subtract the other part, that is se minus s infinity over a squared times sine a infinity minus se minus s times 0 over a squared times sine a times 0. So now we dissolve these parts. When we raise anything to infinity, it tends to negative infinity, it tends to 0. Cos infinity, it tends to 0. When we raise e to power negative s times 0, this is e power negative 0, exponential raised to negative 0, which is exponential raised to 0, which is equals to 1. So this one is 1. Cos a times 0 is 0. Cos 0 is 1. So this is 1 over a, which is equals to cos 1 over a. There is negative that we are forgetting here, which is negative into 0 minus 1 over a. Here together till there. This negative and this negative and this negative and this negative here. This is a negative. So negative 0 minus 1 over a minus. When we raise anything to negative infinity, it goes to 0. Sine infinity is 0. So that is 0 minus. This one is, it becomes 1. When we raise anything to 0, it becomes 1. It is 1. But sine 0 is 0. So 1 times 0 is 0. So negative 0 minus 1 over a, it will give us 1 over a, which is this one here. I1 into 1 plus a squared over a squared. Hope you are together until there. Okay, 1, we make this one a denominator, a common denominator. So this becomes a squared divided by 1 is a squared times 1 is a squared plus a squared divided by a squared is 1 times s squared becomes a squared, which is equals to 1 over a. Now we want to remove this, we move this one to this side, take this one to this side. So we divide by the reciprocal of each other. So I1 into a squared over a squared plus a squared times a squared plus s squared over a squared is equals to 1 over a times a squared over a squared plus s squared. So this one and this one give you 1. So I, now we go back to I is equals to, this one you cancel and this one you cancel, you get it's an a. So a over a squared plus s squared. And that's our answer. Thank you for watching. Subscribe to the channel.